Hey, this is Mike from Minimal 3DP, and I'd like to take a minute to thank everybody that subscribes to my channel and also point out that I've enabled memberships via YouTube for the channel, and I appreciate everybody that's supporting me. Now, with that being said, I'm going to switch over and let's take a look at the latest beta release of OrcaSlicer 2.3.1. So recently, the OrcaSlicer 2.3.1 beta has dropped, and so today we're just going to take a look at these features. Now, I apologize if I've already said this. For some reason, I'm having all sorts of problems with my sound. So part of the video, I'll capture sound, and then the second half of the video, typically I don't. So it's just been a fun couple of days trying to actually record something that works. So hopefully this time, I guess fourth time's the charm maybe. So here we go. So taking a look, the main feature is we're now able to add extra solid infill layers, which is really awesome. And I'll show that feature in depth here in a minute. Scrolling down, they've refactored infill rotation. Previously, it had been a little bit confusing on how you set up rotation for your infill, which can be important depending on how you want the orientation of the strength and which way you have stresses coming on your model. Now, they also fixed some bugs with rectilinear infill, fixed some other bugs with configuration bundles for the importing. And then this one's sort of cool. They improved the Fisher-Koch infill precision, which is basically a set of equations on how it calculates and smooths infill curves. And what's pretty cool is they had previously been looking at things via a lookup table, but now they're actually calculating the actual trigonometric functions, which is pretty cool. Now, one thing I'm going to need to do at some point is pull the source code just so I can look at how things are set up in OrcaSlicer. And again, every time I look at this, it gets neater and neater. They've optimized honeycomb infill. So again, pretty cool stuff that I'm really excited for the stable release. Now I'm just going to scroll up here and talk about this adding extra solid infill. Now, this feature is pretty interesting, where if we look at the animation, what they're doing is they're adding a solid layer of infill, I think every 5 layers on that cube, which can basically add some strength and also add extra strength on area where you're expecting stresses, particularly on a functional part. So this gives us some more power as we're trying to maximize strength of our model while at the same time optimizing for speed and quality. So to look down, there is some notation here. And this is a little bit complicated. In my mind, you just need to play with this a little bit. It took me a couple minutes just trying different settings to figure out what they're saying. So the notation, a number with a number sign followed by another number, this 5 pound 1 means insert a solid layer every 5 layers. I can do the same with just 5 pound. And then here's another example of every 10 layers, they're adding 2 solid layers. Down here, we can specify specific layers where we could say do solid infill at layer 1, 7, and 9. Now, the bottom one's probably the most interesting. This one's inserting solid infill at level 5, and then it's using the pound notation again, and this is adding at layer 9, it's adding 2 solid layers, and the way that's doing is it's adding solid layers and layers 9 and 10. So again, pretty interesting. And then lastly, more solid infill at level 18 or layer 18. So I said, this looks a little complicated, but then when you go over and look at it in the OrcaSlicer, it's really not that bad. So let's switch over and look at the slicer. So I found these little ball and socket models, and I found these, let me switch back over. I found these on Maker World, and I liked those. I thought they gave a good example where you could see really clearly what I'm trying to do. Right now, I have these models. I cloned them, and I have them labeled Model 1 and Model 2. Over here, I'm working with objects. So I'm just doing individual models so we can sort of compare them. If I slice right now, you'll notice the number 1 models are basically straight 10% infill. So all throughout, 10% infill. Now, on these number 2 models, let's look at the ball. What I decided to do was I wanted to try having solid infill through this neck. I felt like this might be the area where I'd need some extra strength. And if you look, what I've done, and let's go over there and take a look at this. I'm going to go under Strength and scroll down to Insert Solid Layers. So the neck starts at about layer 77. And then what I say with this notation is starting at layer 77, there's the pound sign, and then for the next 52 layers, make it all solid. So if we come over here to Preview and look at that number 2 ball, you can see where it sort of starts going to solid infill for 52 layers, and then down here at the bottom. Now maybe that's not exactly how I want it. I can just change it where instead of doing, maybe I need to go up a couple layers here. So instead of 52, let's go 55. Slice it again. And you'll see we can change that. Went up a little higher. Maybe we need to go, let's just go to 60. So we can just play around with it some. Slice the model. And you can see we've basically gone up into the ball there. So again, I could do that solid infill. Now it does take longer. Now on this back one, I tried something a little different. So let's click on that model. And this one, I did 5 solid layers every 25 layers. So let's look at that one. So if we look carefully throughout, and we start down the bottom, so it's going up 25 layers, going solid for 5 layers, back to the infill, solid, infill, all the way up through the model. So again, pretty cool stuff. And this gives us the option of increasing strength, again, particularly in my mind, for functional parts. Now let's switch over. I've printed these out and let's take a look. So as you can see, I've printed them all out. Here are the number 1s. You can see they look pretty good. Maybe a little bit under here because I didn't do any supports, but everything looks pretty good. Now these are the solid infill through here. And need to point out one of the possible problems you can have, as long as I don't drop it, is you can have either some bulging through here or Z-banding. And part of that is you have your infill and then you're putting solid layers on top of it. And because it may be partially melted, still you can have some sagging. So that you might need to do some tuning with how you're doing your cooling on your model. In my case, I'm not seeing any Z-banding. And then on this one, where I did every 25 layers, even just feeling both of these, I'm not feeling any difference. So I think this, again, a pretty cool feature. And in my mind, it's another feature that'll be really handy as I'm doing functional parts and I want to do some added strength. Hopefully you found this interesting. If you have any questions or comments, please post below. Talk to you again soon.